In this video, we will discuss how to use summary statistics to describe the center and amount of spread in a data set. After watching this video, you should be able to explain what mean, median, interquartile range, and standard deviation tell us about a set of data, explain the impact of outliers on the mean and median, compare measures of center and spread between different data sets, and assess the amount of variability in data displayed graphically or in words. We continue to look at IMDb scores for films released in 2018 as we did in the first video. When describing a variable like IMDb score, we should discuss both the center and the amount of spread. Two common measures of center are the mean, the numerical average, and the median, the middle number. We can see from the line in the middle of the box plot that the median IMDb score is 6.5. We'll use R to calculate the mean IMDb score, and that comes out to be about 6.41. In this instance, the mean and median are very similar. In a distribution that is roughly symmetric, as is the case with IMDb scores, the mean and median will be about the same. Now let's examine the distribution of movie revenues in millions of dollars. We see that this distribution is not symmetric at all. Most films are over here on the left making less than 50 million, but we have a tail going off to the right indicating that there are a few highly successful films that made as much as $700 million. A distribution with this shape is said to be right skewed. Using R, we'll calculate the mean and median revenue. The median is about 6.6 million, meaning that half the films made less than $6.6 million while the other half made more. When we calculate the mean film revenue, it comes out to be about 41.5 million. The mean is much more than the median. This is due to the few very successful films like Black Panther and Avengers pulling up the mean considerably. In a right-skewed distribution, the mean will be larger than the median since a few very large observations pull up the mean but don't change the median. In these situations, the median is usually a better indicator of a typical value. Next, let's see how IMDb scores for dramas compare to scores for comedies. These comparative box plots show the distribution of scores for drama on the top and comedies underneath. We see that the median score for dramas is higher than the median score for comedies, but that there's more variability in the scores for comedies as the box is wider and there's also a longer tail, especially going off to the left for comedies than for dramas. We've seen that mean and median are statistics that can be used to measure the center of a data set. There are two common statistics that are used to measure the variability in a data set. One is the interquartile range. This is the width of the box in the box plot. It represents the range of the middle 50% of the data. The second statistic that is often used to measure variability in a data set is the standard deviation. Roughly speaking, the standard deviation represents the average difference between individual observations and the sample mean. The higher the interquartile range or standard deviation, the more variability there is in the data. We saw from the box plots that dramas tend to get higher scores than comedies on average, and that there's more variability in the scores for comedies. Here's a table displaying the mean, median, interquartile range, and standard deviation for each of the types of movies. Again, we see that dramas score higher on average with a mean score of about 6.7 compared to 6.4 for comedies, and the median for dramas is about 6.8 compared to 6.5 for comedies. But we see that for comedies, the interquartile range is 1.15, higher than the 0.70 for dramas, and the standard deviation for comedies is 0.99, which is higher than the 0.81 standard deviation for dramas. This backs up our observation that there's more variability in the scores for comedies than for dramas. In this video, we've talked about how to explain what mean, median, interquartile range, and standard deviation tell us about a data set, how to explain the impact of outliers on the mean and median of a data set, and compare measures of center and spread, as well as assessing the amount of variability in data displayed graphically or in words.